Hey everyone, it's Ben from Board to Bits, and this is sort of a part 2 to last week's launch arc video where we used a line renderer to visualize the sort of trajectory of a launched object. And that works really well if you're doing a 2D game. In fact, the line renderer works perfectly for that, and it can work in 3D. However, there are some sort of eccentricities of the line renderer depending on your camera's angle in 3D. So I wanted to show, if you really wanted some control over how your launch arc appears, how to create a custom mesh that represents your launch arc. And so I'm not going to go through the calculations of creating the launch arc again. We did that last week, so if you'd like to see that, I encourage you to watch that previous video. Instead, right now I want to just kind of dive into showing how to create this, instead of you just inputting the information into the line renderer, creating a custom mesh using that calculated data. So first thing we're going to do in here is we're going to kind of shift this view. Right now this project is set up as a 2D project, but we can get it into a 3D mode pretty easily. So we're going to click and turn off the 2D up here in the scene view. So that gives us actual 3D motion that we can see here. In addition, our main camera, I'm going to switch from orthographic to perspective, which you notice changes the view a little bit differently here, but it just is a little bit more realistic for as we're looking at what will be this mesh. Now down here, we're still going to be able to use this arc line. This is an unlit shader, and that will work fine for actually visual. We can use that as the material for our 3D mesh as well. I'm going to create a new C# script down here. I'm going to call this launch arc mesh. And I'm going to create a new game object in our hierarchy. I'm going to create another empty. I'll reset its position. And this one I'm going to call launch mesh. In addition, on this, we obviously we don't have any components on this right now, but I'm going to add to it a mesh renderer, which will, I guess it doesn't automatically add a mesh filter. I thought it did, which will also add a mesh filter to that. I'll actually move that up. Kind of the traditional format here. The mesh filter is what actually holds the mesh information, and then this mesh renderer will put that onto the screen for us. If you'd like to know more about how the whole rendering system works, I encourage you to watch my custom mesh series. I did I think about a dozen videos on that, and a few different ways that you can create meshes. So like I say, I would encourage you to watch that if you want the ins and outs, but I will take you step by step through this process now. So with these things created, lastly I'm going to add the launch arc mesh component on here as well. Now I'm going to open up launch arc mesh in MonoDevelop along with the launch arc renderer script as well. And I'm actually going to copy and paste everything from the renderer. And I'm going to paste that right into here because we are going to be using a lot of it. Do make sure to change the name of the class back to launch arc mesh. And instead of requiring a component of line renderer, we're just going to require a mesh filter. We can delete the line renderer call here. We don't need that. However, I am going to put in a variable called mesh, and it's going to take a mesh type object. In addition, I'm going to make a public float variable, and this is going to take the mesh width. And what that is basically going to say, if we want our arc to be 1 unit wide, half a unit wide, bigger or smaller, that's how we're going to control that information right there. We need to keep all of this information because that is pertinent to our arc itself. We no longer need the line renderer to get the component. However, we do want to say mesh equals get component mesh filter dot mesh, and I believe that's all we need in our awake function. Down here we can change, we're going to keep this on validate, which basically says whenever, if we're playing the game and we change the values, we can see the arc change in real time. I'm going to make sure that we'll check that the mesh is not null now instead of the line renderer. And if that is the case, then we will call what we're calling render arc right now, and that still I'm going to change the name of this slightly. I'm going to call this make arc mesh, and that's going to be a new method that we'll create. Down here, this will also become make arc mesh. And this render arc, which was where we were currently, kind of using the line renderer, we're going to change this to actually be, we're going to get rid of this method altogether. These two methods are how we calculate the arc itself, so we'll keep those. But we will now create our void make arc mesh method. So when we were doing this with the line renderer, we were just using the line renderer itself's methods to populate its information. In this case now, I'm actually going to be doing everything right within this method, so I need that array of vector 3s for those vertex positions. So I'm going to make that a parameter here. We're going to say, we're going to ask for a vector 3 array, and we'll call this arc_verts, because it's the vertex information of our arc. What I'm going to do up here is we are going to call make arc mesh, but what we're going to do is we're going to pass in the result of our calculate arc array. So we'll say calculate arc array, do that method call there, and we'll do that as well up here. So that's just simply saying we're going to make this arc mesh using the vector 3 array that we create in this method. So this is where we're actually going to create the mesh itself. And we're going to do this, the first thing we're going to do is we're going to say mesh.clear. Because whenever you're changing, and because we're going to use this in the onValidate method, we may be changing an existing mesh, you want to make sure that you clear out all the information so your vertex information and your triangle information never kind of gets confused. Like you don't have old vertices with new triangles, which could cause like out of bounds array issues and things like that. So mesh.clear. The next thing we're going to do is we're going to create a vector 3 array called vertices. And this is not the same thing, mind you, as our arc_verts, because this is just literally that sort of graphed x versus y information kind of on a 2D plane. This is now going to be the 3D information that we use to create the vertices of our mesh. And then we're also going to have an int array called triangles. Now we need to set the sizes of both of these based on the resolution of our mesh. And so for vertices, that's going to be equal to a new vector 3 array of size resolution +1. And that +1 is because our very last segment needs to have an endpoint as well. And we'll multiply that by 2 for the two sides, the left sides and the right side of the sort of arc, the ribbon of the arc. Likewise, for triangles, we need to set the size of this as well. So we'll say new int array, and its size is just going to be resolution. It's not going to be +1 because it's literally just the number of segments multiplied by 6, because every quad is 2 triangles, which is therefore 6 vertices to keep track of. With that, we can now actually just start iterating through each segment of the arc and figuring out where the vertices go and telling the triangles which vertices they should reference. So first thing we'll do here is we'll say for int I equals 0, I is less than or equal to, and that equal to is important here, the resolution, because that's again, this is kind of the equivalent of this +1 over here. We do want to include one extra iteration of this so that we can get those endpoints put in. And then we'll say I++. Now the first thing we need to do in here is we need to set vertices. And so we'll say our vertices at I times 2. So this is going to be basically all of the even numbered vertices, 0, 2, 4, 6, 8. We're going to put these on the it doesn't really make a huge difference which side you do this on, but I'm going to put these on the right side of the arc mesh. So we'll say new vector 3. And what's going to be a little bit weird here is that we have, obviously we're going to have an x, a y, and a z component. I'm not going to be putting the x information of our arc into the x here, because when you're launching something in a 3D space, you're launching it forward, and the forward axis is obviously the z-axis, and then side to side is x. So this is really going to be the width. This x here is going to be the width of our array, or sorry, of our arc, and then y is still the height, but then z is really the distance. So the z is where we're putting that x information of how far along the arc we are. So for x, we're actually just going to say mesh width times 0.5f. Y will be that y information, so that will be arcverts I dot y. And then z, like I say, is the horizontal distance we've gone on the arc. So that will be arcverts I dot x. So we're kind of, like I say, we're converting what was a 2D arc on an xy plane to a 3D arc on a yz plane. That's probably the easiest way to describe that. So that gives us one side of the arc. And what gives us one side of the quad, if you will, that we're creating for each segment. So to do the other side, we need to basically, we're going to do the same thing here, but we're going to make this a negative. So we're going to copy all this, paste it here, and we'll say negative times a negative half, so that we're got the x on the other side of the mesh. And then this one, we want to do all of the odd numbered vertices. So basically we can take that in the same way that this is 0, 2, 4, 6, we want this to be 1, 3, 5, 7. So we're just going to add 1 to that. And because of order of operations, this will happen first, and then we'll add the 1 afterward. So with all of that, now we can add triangles. So we'll say set our triangles. However, we only need to set triangles on everything except for the very last iteration, because that last iteration is really just the two endpoints and doesn't need a new set of triangles for another segment beyond it. So what we can quickly check here is we'll say if I does not equal resolution, meaning we're not on the very last iteration, then we set triangles. This will just make sure that we skip it on the very last iteration that we're doing. Now what we'll say is triangles I times 12, and the reason that I'm saying 12 here, and actually is because I forgot something above in the when we initially set this triangles array, which is that if you just create one side of the meshes, your arc will look okay, but then the underside won't be there at all. Like, so if you were to say go under your arc and look, you wouldn't actually see anything, which is kind of weird. So we really need each of these quads, each of these segments to be double-sided. And for that reason, we're actually going to say, instead of just resolution times 6 for the triangles, we're actually going to multiply that by another 2 for a total of 12 times the resolution, so that we have 6 triangle vertices for the top of the arch, and then 6 more for the underside of the arch. So that's why we're saying 6 times 2 here. Likewise, 6 times 2 is 12, so I'm just going to put it as 12 down here, but that's why we're multiplying all these by 12. So the very first point is going to just be that I times 2, that very first vertex that we created. The next two are triangles I times 12 plus 1, and I'm just going to start copying this, and plus 4. And this again is something that I go into much more detail in my custom mesh series, so I'm just going to kind of breeze through it here right now, but suffice it to say this is how you create a simple quad, is that you're trying to basically create 2 clockwise triangles. Will give you basically these 2 clockwise triangles that share a side will give you a 4-sided object that you can see when you're in your game rendering. And so that one is, I plus 1 times 2. Copy all of this. And this is now going to be plus 2 and plus 3. And this one is I times 2 plus 1. And then finally, we have triangles I times 12 plus 5. And this one is kind of an amalgamation of the two. It's I plus 1 times 2 plus 1. And basically, this is saying get the very first vertex we created. This one is saying get the second vertex we created. This one is saying get the first vertex of the next segment. And this one is saying get the second vertex of the second segment. So it's just iterating through those four, like the two that we created and the next two we're going to create for each set of triangles. And again, this is obviously why we're not doing this for the very last one, because there is no next set of triangles that we're going to be, or next set of vertices that we're going to be creating. Now this just gives us the top half. We're also going to have to create the bottom half of the arch, or the bottom side of the arch. So I'm going to copy all these again. And basically now I'm just going to be adding 6 to all of these, because we have the first 6 triangle points here, and this is going to be the next 6, so that we go through all 12. And then that's why when we iterate again, it's multiplying by 12, so we're starting at 13, 14, 15, etc. So here I'm going to say plus 6, change this to 7, 10, plus 6 is 8, 9, and 11. And with all of that, we now have our full mesh, our 2 arrays that we need. We have our full vertices array and our full triangles array. So we can set that mesh variable that we have. We're going to set its vertices equal to that vertices array we just created, and mesh.triangles equal to the triangles array we just created. Now I'm not going to set the normals on this. Normals are what kind of shows how light will hit things, because we're doing this with an unlit material, so that really doesn't matter right now. If you are using a lit material, you will want to recalculate normals. However, what you'll probably also want to do in that case is double your amount of vertices, so that you can your undersides and your bottom and your top can have discrete vertices that they're working with. It makes the mesh a little bit more complicated, takes a little bit more information, but that's how you do that. Like I say, that's why I'm running this right now with an unlit material, so it's pretty easy for us to get from here now to seeing how it will look in the scene. So with all this information, we should be in a good place. If I jump back here now, go to our launch mesh. I'm actually going to turn off our launch source for right now. Let's give it a width of about 0.5. Velocity, what do we have for our information up here? It was 5 and 45, give or take. So velocity of 5, angle of 45. If I hit save here and hit play, what we should see appear is we'll get the mesh, we'll populate here, and we will see what looks like a single, oh, we didn't have the material on it either, but what looks like a single, okay, that's interesting. We've got the arc appearing just as we want it on the underside. However, the top side is not rendering for us. That's interesting, and not what should be happening. Oh, I know why. In order for the top side to render, we actually need to reverse these two here. So what I'm going to do, right now this is actually just rendering, or this is, like I said before, you have to make your triangles in a clockwise order. And all I'm doing here is I'm doing this and this, 2 sets of triangles in the exact same order, which is why only one side is rendering. But what I can do is I can quickly cut this, paste it here, and then just cut this and paste it here. And that swaps that single pair of vertices around, which makes it so that the 2 triangles are now, this set of triangles is going in like clockwise, and then this set is counterclockwise, so that we will see, if I go back to Unity and hit play now, we get both sides of the arc. Now that is a bit wide for the arc, and I also want to apply the material. So let me go into materials here, apply the arc line material we had before. We'll hit play. And now what we can do is I can adjust this mesh width right here, and you see because of that onValidate method that it changes as we right in real time as we do it. I can also increase the velocity, and that increases the arc itself, as well as the angle, which will actually change. So again, same appearance in a way as the line renderer, but we have a little bit more control. It's kind of this ribbon look to it. You could apply a texture to this and have like a big arrow that's moving, things like that, but it just gives you a little bit more control over how this appears in 3D space. So thanks so much for watching. Hope you find this useful for your game dev, and I'll see you next time.